Consider a large ensemble led by and there are innumerable stars, planets, and moons playing together in perfect harmony. However, a particular section of this orchestra has baffled experts in space. For an extended period, exoplanets. Exoplanets are typical planets located outside our solar system, hidden deep. You might be in the Milky Way, surprised to learn that among there are numerous celestial bodies. Exoplanets so strikingly similar to, so that they might belong to our planet's celestial twin. Let's delve into the fascinating region of Proxima B, a mere 4.2 light-years away. The James Webb Space Telescope is guiding our journey to uncover the secrets of these cosmic wonders. Now imagine your mind exploring the vast expanse of our universe, which includes the Milky Way, over a quadrillion potential exoplanets. This number into perspective, assuming that each one of these exoplanets were the size of, we wouldn't just fill with sand. If we lived in the Grand Canyon, we'd have enough to create a second earthly monument. A Grand Canyon 2.0 extends over a colossal distance. It's truly astonishing that about 20% of these enormous objects been classified as Earth-like in both terms of geography and atmospheric conditions. This means there's a 1 in 5 chance of finding a planet identical to ours, and the narrative does not end there. These planets may be accompanied by another quadrillion moons, rocky satellites like our own moon, engaged in a dance of attraction with their parent planets. If you manage to contemplate locating a different world in space that harbors life or could potentially do so, there are an abundance of possibilities. After we've looked at them, the vast scale, it's time to introduce the effective instrument for analyzing these cosmic intricacies, the James Webb Space Telescope. This celestial detective, with its expanded central lens replaced by adaptable mirror segments, performs better than even the most cutting-edge optical instruments. We're not talking about just any lens. It has a 6.5 m primary mirror, 2.7 times larger than Hubble's, enabling it to distinguish even the tiniest of light from stars far away by billions of light-years, and to scrutinize the details of orbiting planets. What sets the James Webb the telescope stands out not only for its immense power but its cutting-edge technology, including advanced sensors and spectrographs. These tools do far more than simply observe. They analyze and transform light emitted or reflected by distant objects to interpret their atmospheric conditions, composition, density, and even mass. Acting as a cosmic researcher, the telescope can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space the telescope has the ability to answer these questions, elevating it from a mere observer to a scientific genius. It's not just an upgrade over Hubble. It's more like a quantum leap. If Hubble's discoveries amazed you, prepare for a true event of radiant revelations. As we expand our gaze across the intricate fabric of the universe, it's worth concentrating on a single star in this cosmic symphony, Proxima B. Since its discovery in 2016, this intriguing planet has captivated astronomers and scientists alike with its complex nature, filled with enigmas and mysteries. So what makes this planet so special? Firstly, Proxima B is remarkably close to us, located just 4.2 light-years from. To put that into perspective, Earth, you could break the universal speed limit and travel at the speed of light. You'd arrive in just over 4 years, roughly the same amount of time it takes in order for your favorite show to season. But let's dive deeper into why this proximity is so exciting. We're talking about a universe that stretches over 93 billion light-year from one edge to the other. Finding such a close planet, and one so promising for scientific exploration, is like finding a precious stone. A gem that could be found in a mountain of stone, hold answers to life's questions. Not only is Proxima B significant in and of itself because of its proximity to Earth, but also due to its intriguing characteristics that suggest it might not only be Earth-like but perhaps even within Earth. 2.00 Proxima B's orbit the habitable zone of its stars, a region where conditions are neither too hot nor too cold, making it possible for liquid water Imagine winding waterfalls for existence. Rivers, vast lakes, and maybe oceans as deep and mysterious as the Mariana. However, before we begin imagining, the trench our future there, so let's think about some. It only appears once per day on Proxima B. Imagine a staggering 11 Earth day sunrises that don't rush in but unfold, slowly resisting the usual pace of day and night, creating brilliant golden hours that photographers dream of. While this might sound idyllic, it also has significant effects on its climate and potential habitability. How would human bioithms adapt to the slow rhythm of light and darkness on Proxima B? Would we need to eat much more often on that planet? How would our sleeping habits change drastically? The basic life patterns, the two things we're used to on Earth, would be tantalizingly familiar and frustratingly unfamiliar. It appears that nature is presenting us with a riddle wrapped in yet another puzzle that tests our understanding of what makes a planet livable. How can we gather precise and reliable data about a world we've never visited? Enter the James Webb Space Telescope, which acts like a giant Swiss Army knife for space exploration. It's more than just a telescope, it's an incredible research laboratory operating in the vacuum of space. Thanks to its innovative technology, cosmologists can not only observe planets but also analyze them with an arsenal of scientific instruments that would even CSI labs seem basic. By studying the light emitted or reflected by these distant planets, researchers can perform a sample from one of these celestial bodies, determining the density of the atmosphere and whether essential substances like water, carbon molecules, or even oxygen are present. Space science is no longer just about stargazing, it's a form of cosmic forensics. We're not waiting for clues to come to us, we actively search for them, probing the molecules and atoms that make up the James's far-off world's Webb Space Telescope isn't just an eye in the sky, it's a highly specialized research lab ready to transform our hypotheses and theories about alien worlds into confirmed knowledge. But the story doesn't end there. Researchers recently, using the James Webb Telescope, discovered something completely unexpected from Proxima B, an unusual signal that it spread quickly throughout the academic. This is a sign from social media and circles, which has been suggested by some to be emitting technological signature waves of electromagnetic energy that were complexly structured and perplexing, possibly indicating the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop as the news spread, offering the potential breakthrough we've all dreamed of, the evidence that we are not the only ones in the universe. But as quickly as it appeared, the signal vanished, leaving a haunting silence and a wave of unanswered questions. Was it just a fleeting cosmic anomaly, a strange coincidence, or was it something more deliberate, a coded message or a sign of extraterrestrial intelligence? This singular discovery cast a shadow of mystery over Proxima B, igniting passionate debates and new theories. Could this be a subset of a larger story that was more complex than we could handle? Have ever imagined the quest is far from over? Harvard scientists leading a shift in perspective are now pushing the boundaries of space exploration. They're not content with just analyzing the signals and anomalies we've uncovered so far. They're planning to turn the James Webb Space Telescope into a cosmic night vision device. They intend to search for artificial light sources across the dark and illuminated regions of distant worlds. The potential for such discoveries is staggering. Imagine spotting the city lights' faint glow on another planet, artificial light sources that may indicate the presence of an advanced civilization. Could we one day see cities lit up with intelligent beings delivering their luminescence across the vast expanse of space? As we proceed to investigate the universe, the search for extraterrestrial life takes on a new depth, moving beyond just Proxima B. Our journey now spans massive new regions of space, driven by technological breakthroughs and an insatiable curiosity about our place in the cosmos. We are expanding the frontiers of space exploration like Never before have exoplanets been discovered, with potential for habitability is just. From the beginning to the end of our investigation is more than just seeing new places, but about redefining what it means for a planet to be habitable. As we peer deeper into the vastness of space, we find ourselves questioning whether life can completely exist in environments different from our own. Could life thrive on planets with extreme temperatures, oceans with toxic or high radiation? Could the alien life forms are so radically different, so dissimilar to ours that we can barely comprehend them? The discovery of extreophiles on Earth, organisms that can survive in extreme conditions, has already put our presumptions about life's resilience, from bacteria thriving near boiling hot springs to microbes existing near deep-sea vents. Earth's extreophiles show us that life can adapt in ways we never imagined possible. Similar life forms, or even more strange. Additionally, there are planets where alien life forms we once believed that life could not continue as artificial intelligence and machine. As we continue to learn, our abilities improve to process the data we collect from distant planets grow stronger. These technologies allow us to sift through vast amounts of information, searching for patterns that humans might miss. With the help of these powerful tools, astronomers can now identify exoplanets with remarkable precision, narrowing down the list of candidates for habitability. The upcoming class of space telescopes may bring us even closer to answering one of the most pressing issues facing humanity: is we alone in the universe? Meanwhile, the potential for detecting techno-signatures, the faint traces of advanced technology from far-off cultures, has sparked new discussions. What if we are not only interested in biological signs but also clues that intelligent alien civilizations exist? Could the patterns in the light from distant exoplanets reveal a signal sent deliberately toward us? The discovery of Proxima B's strange signal has reminded us that the universe still possesses numerous challenging surprises. Our notions of what might happen if the James Webb Space Telescope uncovers even the faintest trace of extraterrestrial intelligence. It would be a groundbreaking moment in human history, one that would make us rethink our position, everything we know about life, the universe, and our place in it. As we embark on this grand voyage of discovery, we must ask ourselves, what is our place in this vast universe that is always expanding? Should we get in touch with extraterrestrial civilizations? If we find out for them, what our responsibilities are bear as we explore worlds beyond our own? The future of space exploration holds promise, excitement, and the potential for revelations that will expand our comprehension of life as it exists today. The verge of a new era.